All right, hi kids. Um, so we're going to try something a little different. It's going to be good because when I'm on maternity leave, this is how we're going to learn. And if we end up having to go to online school, then this is how it's going to be too. So bear with me. I'm new at this. I'm going to be slow at getting stuff recorded and slow at talking and thinking, but it'll get better, I promise. The more I do it and the more you do it, the easier it'll get. So let's go ahead and open our books. I want you guys to turn to page number 1. Page number 1 is showing you that we are starting a brand new unit. It's called Unit 1, Proportional Relationships. And what you're looking at is the self checklist. So what I want you to do is I want you to go through each of these things. You can pause the video, and I want you to ask yourself, can you do this right now? And if you can, you say, yeah, I can do this now. If you can't do it, leave it blank. Okay, and don't worry about the after column. That's what you look at after the lesson. So let's say, like right now, I definitely can find actual distance given scale drawing. So I can say, yep, I can do that before. But let's say I can't find actual area given on a scale drawing. So then I'm just going to leave it blank. I'm not going to click this because I haven't learned it yet. So just leave it blank. All right, go ahead and go through that checklist. You can pause the video, go through your book, and I want you to check the things you think you can do now. There's no shame if there's really not very much you can do. That's totally fine. Okay, so we're going to move on. Don't forget, you can always pause the video. That's what's so nice about me recording these videos is that if you're somebody who thinks your teacher goes too fast, you can always pause and go at your own pace. If you're somebody who like already knows all this and you're just like, come on, lady, get on with it, then you can just, watch it quickly. So we are now on page 2, and we're going to do a quick little it's just like a pre-lesson. It's not the real lesson yet. The real lesson starts on page number 5. But we're not there yet, so we are on the pre-lesson. And today I think what we're going to do is just do the pre-lesson. And that way you'll have no homework for tonight because that would be a very mean teacher giving you homework on like literally the second day of school. So don't worry, no homework tonight. But let's go through the pre-lesson. Okay. Now remember that proportional relationships have a lot to do with ratios. A ratio can be written as a colon. It can be written with the words to. And you can also write it like, well, I believe that's maybe all we can do. We'll find out. Oh, a fraction, doi. Okay, so like, I don't know, 6/12 is also a proportional relationship. All right, let me erase. I told you I'm going to be slow at this. I have to like warm up, okay, guys? Like school hasn't even started yet. I'm recording this a week before, so like my brain is still in summer mode. So, be nice to me, please. Okay, you have learned to reason about ratio concepts and equivalent ratios. Find the ratio of G to H for each group below, and write the letter of the group in the correct column in the table. Okay, so remember, if it says G to H, you have to do G first. So let's just go through these. Let's go through A first. Let's count how many G's there are. 1, 2, 3, 4. Okay, so there's 4. And then how many H's? 1, 2, 3. Okay, so A would go in the column 4 to 3. And looks like they already did a nice little A for us right there. Let's do B. How many G's are there? 1, 2, 3, 4. Okay. How many H's? 1, 2, 3. Oh, look, another one that goes in that column. B. All right, let's do C. How many G's? 1, 2, 3, 4, 5, 6. And how many H's? Only one. So, oh, I almost missed it. I was looking for the column. There it is. C. Okay. Now, what I want you to do is I want you to do the rest. I want you to do D, and I want you to do the rest of these and put them in the right spots. Okay? And pause the video right now, and I will fill in the answers and you can check your work. All right, pause the video. For real. Pause it. Do as I say. Did you pause the video? Did you fill in your answers? Okay, well, if you filled in your answers, we can check your work. So this is D, this is J, E, F, H, G, L, and I, and K. Okay, now let's look at the bottom. Find the ratio of G to H for the group below. Which column would this guy fit in on the table above? Now, I know the first thing you're thinking is, holy cow, Mrs. Ringler, there's way too many G's and H's to fit in that table. Like, there's no possible way, Mrs. Ringler, that's going to fit in there. Well, remember, here's the cool thing about ratios. Remember when I said that ratios can be written as a fraction? We also know that fractions can be reduced. Do you remember what reduced means? For example, it's like if I had, oh gosh, I just need a random one. How about 15 fifths? Okay, we can reduce that. It's also a improper fraction, but we can reduce it by finding out what can I take out of both of these, like multiplication fact-wise. So what do they have in common? 5 times 1 is 5, and 5 times 3 is 15. So if I take out a 5 in both of these by dividing it out, I get 3 over 1. What do we know 3 over 1 is actually equal to? Yeah, big fat whole 3. Okay, well that was just an example of reducing. You just got to remember you can reduce, okay? So let's go ahead and count our G's. Let's count our H's. Let's do G's first. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So there's 12 G's to how many H's? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, 12 to 9. Now, is there a 12 to 9 column up here? Definitely not. So that means what we need to do is we need to reduce. So think of this as 12 over 9. What can I take out of both of these that they have in common? I know 3 times 3 is 9, and I know 3 times 4 is 12. So I can take a 3 out of both of them, and then I'm left with 4 thirds. Now let's rewrite 4 thirds in this form. All right, so where would I put this GH, 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 whatever? Where would that go in this table? Yep, it would go right there. Perfect, 4 thirds. So the big thing that I want you to remember on this is that ratios can be reduced because a ratio can just be written as a fraction, okay? Ratios and fractions can be reduced. Okay, remember that was just the pre-lesson, so hopefully this was not all new information to you. If it was, definitely come find me and we can do a few more example problems. Okay, let's go ahead and turn the page. Now, your next page is a Dear Family letter. I'm not really like the elementary school where it was like, okay, tear out your dear families and send them home. I'm not really about that life. I mean, if your parents want to read it, that's fine. But I'm more interested on what's on the back of the Dear Family. So if you turn the page after your Dear Family page, you'll see you're on page 4. Now, this still is the pre-lesson. This is not the real lesson yet. So that's good news for you guys because we're just going to take this nice and easy. So what's cool about this book is on the back of the Dear Families is kind of like this fun little like activity thing, okay? Now, we're not always going to do the activity, but every now and then when I feel like we have some extra time or the lesson was super short, we probably will do the activity. So let's go ahead and read through it right now. Get my little pointer. Okay, thinking about scale around you. Do this activity together to investigate scale in the real world. Have you ever taken a long road trip and come across it's a sculpture in Texas. They are over 35 feet tall. A cowboy boot is normally just like 12 inches or a foot tall. Gift shops often have models of buildings that fit in the palm of your hand. In Washington, D.C., you can get a Lincoln Memorial model that is 6.5 inches tall. The War Memorial is 80 feet tall. These giant and tiny models are scale copies of real-life objects. I've seen a few scale copies of things in my life, and it's really awesome when they actually are mathematically to scale. So the question says, where do you see scale drawings and scale copies in the world around you? I want you guys to really think about this and give me at least 3 to 4 examples, okay? So give me 3 to 4 examples of where you see scale drawings and scale copies around the world. I'll give you an example. So another DC example, because I was about to give that example, but how about this one? I went to New York. Okay, and I went into the Empire State Building. And when I was in the Empire State Building, they have a little gift shop. And inside the gift shop, you could buy a keychain that had a miniature, like, building floating in water. It was kind of weird, you know. But that building was to scale of the actual building. Another thing that I've seen are blueprints for a house. Now, if you're in the contracting business or a construction worker, blueprints are super, super important, because if they're not to scale, then everything else is going to get messed up while you're building. So I created a blueprint of my living room, for example, when we were getting new furniture, and it was not to scale. Like, it was just like me just doodling, and things did not fit how I thought they were going to fit once the furniture was all there. So super important to actually have measurements and your math done correctly. All right, let me think of one more. I know that there's this really cool giant ball of yarn. I don't know what state it's in. Maybe I need to Google it. But there is a giant, house-size ball of yarn as a roadside attraction that you can go see, which is crazy. And I believe it's to scale. Like, if you had a real ball of yarn, what it would look like is just, crazy different. So yeah, there are my 3 examples of where I would see scale drawings or scale copies in the real world. What I want you to do right now, since this is our last page for the lesson, because I don't want to start lesson 1 yet, this is your homework, and you get to do it right now in class. I want you to pause the video, and I want you to come up with your own 3 scale drawings. If you want to borrow one of mine because you're just so confused, that's fine. But hey, get on Google, type in scale copies of inanimate objects that are roadside attractions. Like, there are so many weird things out there. Go ahead and do that, and then here's the crazy part that we have to learn how to do. What you're going to do is, after you have filled out this page, and I will have taught you how to scan, we are going to scan this page, and we are going to upload it to the Google Doc. Now, don't panic if you don't know how to do that yet. I'm going to teach you, don't worry. This is where your smartphones or your iPads are going to come in handy, and they're going to be super important. If you don't have an iPad and you don't have an iPhone that you can take pictures with and scan, this is where your parents' iPads or phones are going to be super important too, because I know they all have smartphones. If they don't, then we'll find you another option. But you can always use your parents' smartphone to scan something for school. Okay, so that's the end of the lesson. Like I said, it's going to be bumpy, it's going to be weird, but don't worry, it'll get better. All right, bye guys.